Hi everyone, it's Mr. Baker here with another physics video. Today we're going to be looking at nuclear fusion. Okay, so today we're going to be looking at nuclear fusion and we're going to be answering this question: where does the sun get its energy? So, nuclear fusion is what powers the sun and other stars. During fusion, small nuclei join together to form larger nuclei and energy is released. The core of the sun is 15 million degrees C and the particles are under huge amounts of pressure. Hydrogen nuclei fuse to form helium nuclei and release vast amounts of energy. Nuclear fusion then is the process of joining smaller nuclei to form larger nuclei and energy. And it starts off in the sun looking something like this. So we have two isotopes of hydrogen. They're under immense amounts of pressure and they collide together. And as they collide together, they fuse. Fusion occurs, releasing lots of energy. And helium is then produced and a neutron is also produced. It's difficult to force protons together because of their repulsive electrostatic force, so it only occurs at very high pressures and temperatures. High pressures to squash them together and high temperatures so that they're moving really fast so that they overcome those electrostatic forces that are trying to push them apart. These are the conditions where it occurs in stars, but it's extremely difficult to recreate these conditions on Earth. So scientists are trying, and there are different projects around the world trying to fuse things together. Now we can fuse things together, but the amount of energy it takes to fuse them together at the moment is more than the amount of energy that we're really getting. It's not worth using these fusion reactors as ways of making electricity at the moment. So to overcome the repulsion between protons without the immense pressures of the centre of the sun, we would need temperatures of about 150 million degrees on Earth. To contain the gas at this temperature, scientists use magnetic fields to contain a donut-shaped plasma. And you can see a diagram of this on the left. So we've got these rings that create magnetic fields, and inside that, because there's a plasma, the plasma is electrically charged, and so it can be contained by a magnetic field in this donut shape. The idea is that the heat produced during fusion would then be used to generate electricity. So, quite a short one. This is what you should be able to do. You should be able to describe how the sun gets its energy. You should be able to describe why high temperatures and pressures are required for fusion to take place. You should be able to complete a nuclear equation showing simple fusion processes. And you should be able to describe the key design features of a nuclear fusion reactor. Okay, and so we've answered this question then. Where does the sun get its energy? Well, it gets its energy by fusing nuclei together. As it fuses them together, they make heavier elements and it releases immense amounts of energy. Smallish stars like our own, like the sun, will fuse hydrogen together into helium. Larger stars will be fusing elements up to iron together. And you'll look at a little bit more of that when you look at stars and when you look at the life cycle of a star. Okay, so I've been Mr. Baker. This has been another physics video all about nuclear fusion, and I will see you next time. Thanks very much.